Wind energy is an important and growing source of renewable energy. TU Delft is constantly researching new and better solutions for the production of renewable energy. There are different methods to produce energy from wind. The most common method is through the use of wind turbines. They convert kinetic energy from the wind to mechanical energy. Through the rotational movement of the blades, an electric generator then converts this mechanical energy into electric energy. We wondered whether it is possible to produce energy from wind without the conversion via mechanical energy. It is, by letting the wind move charged particles against the direction of an electric field. How does that work? This is an electric field and a positively charged particle. This could be any object that can hold charge, for example, a ping-pong ball. But for the EWICON, we use water droplets. The electric force of the field moves the particle towards the negative electrode. Now, when we let the wind push the particle towards the positive electrode, the potential energy of the particle is increased, similar to pushing a rock up a mountain against gravity. This increased energy can be collected using different methods. We start with the first method, which is the easiest to understand. The charged particles are created at the charging system consisting of nozzles and electrodes. The wind transports these particles to an insulated collector, causing the voltage of the collector to rise. The electric energy stored in the collector can be converted, transported, and used for everyday appliances. So we can see we need two separate components for this to work. Fortunately, there is another method that only requires one component. The charging system itself is insulated from Earth. There is no separate collector present. Spraying positively charged particles from the charging system will leave negatively charged particles behind. This decreases the voltage of the system. This is the method we use for the EWICON. Currently, a working experimental prototype exists on a small scale. We need more research to achieve a full-scale version. If this scale-up is successful, then the EWICON could look like this. However, the good thing about the EWICON is it can come in many different shapes and sizes. It is modular, expandable. It can be placed at sea, alone or with many. And because the EWICON has no large moving or rotating parts, it causes less noise, no intermittent shadows and less vibrations. This makes it extremely suitable for urban settings, on top of buildings, alongside dikes, and many other possibilities.